Fine. Hey guys, welcome. So we are going to be talking about adding and subtracting rational expressions. So just like adding and subtracting regular fractions, to do this you must have a common denominator. If you don't have a common denominator, you can't add any fractions at all. The way we make them common denominators is we multiply by a fancy form of 1. So what that means is basically anything over itself. So like you've got a few examples here, like 2 over 2, 3x over 3x, x minus 4 over x minus 4. All of those simplify down to a 1. And when you multiply by 1, you're not really changing anything. So after you get the denominators to be the same, then you add or subtract the numerators. Now remember, when you add or subtract, you do not add or subtract the denominators. They must stay the same. So our first two examples have denominators that are in fact the same. So denominator at the bottom. So these are both 21x. So that means we can go ahead and add the numerators. We're adding because of this symbol here in the middle means we're going to add. So what this turns out to be is 5 plus 2, and then the denominator stays 21x. Well, 5 plus 2 makes 7, and 7 over 21x. Now, before you say, yay, I'm finished, make sure you can't simplify the fraction. So we have this 7 over 21 here. 7 over 21 simplifies down to 1 over 3, and then the x tags along. So your final answer for this, the most simplified version, is 1 over 3x. Okay? Now, when you're subtracting comes a little bit more difficult because we still need to look for, first of all, make sure the denominators are the same, x minus 5 and x minus 5, so we're okay there. But when you subtract, you have to take this little minus and distribute it to both of these. So what you really have then is you really have the 4x. Then you're going to have a negative 3x, because a negative and a positive makes negative, minus 2. You have to make sure you distribute that negative to both things, or all three things if there's 3 of them. Then, once we're here, we're going to collect like terms. So 4x and negative 3x are going to get combined together to make just an x minus 2 over x minus 5. Now, since these are not the same, I can't simplify this any further, so your most simplified version is this. Okay? Those are the two most basic types we have. So let's get into more of the ones you are going to see. So these are the ones you're going to see with the unlike denominators. So first of all, we have to factor the denominators to see what we're dealing with. So if we look at example 3, we have a 5 in one and an x in the other. Both of those are as factored as they're going to get. I can't make a 5 any lower or an x any lower. So now we have to determine what factors are needed in which fractions to make the denominators common. So what I mean by that is decide what you need to make them the same. So in the first fraction we have a 5, but we don't have an x. So this fraction needs an x. In the second fraction, we have an x, but we don't have a 5. So this one needs a 5. So now that you know what they need to be the same, that's what you're going to multiply by in order to make the denominators common. So we have our first fraction, x minus 3 all over 5. And what we're going to do is we're going to multiply by a fancy form of 1. And we said earlier that it needed an x, so we're going to multiply by x over x. Then we have plus 5 over x, and this one we said we needed a 5, so we're going to multiply by a fancy form of 1, 5 over 5. Let me fix that to make it look more like a 5, not an s. Let's try this again. 5 over 5. Now that we have what we need, let's multiply and make sure that our denominators are actually going to be the same. So this x gets distributed, so we've got 8x squared minus 3x all over 5x, plus 5 times 5 makes 25, and x times 5 makes another 5x. So now these are in fact the same, so we did do it correctly. We did use the right fancy forms of 1 to make them the same. So next thing we need to do then, well, now that they have common denominators, we are actually going to just add the numerators. So that's our final step here. So we have 8x squared minus 3x plus 25 all over 5x. Okay? The last thing we need to do is we need to see if we can factor the numerator and maybe cancel some things out like we did when we were multiplying these expressions together. So if we look at our numerator, I have an 8, a 3, and a 25. I can't take out a common number. There's 3 terms, so this would now be the AC method if we are able to factor this guy out. So we would take 8 times 25 to make 200, and you'd have to add up to be a negative 3. Now, I've gone through this, and there aren't any numbers that multiply to 200 but add to negative 3. So this actually does not factor any further, so that means this is as simple as you're going to get this rational expression. Okay, so let's try number 2 with the same steps. So step 1, factor the denominators to make sure that I can find common denominators. So first we've got x minus 4, which this will not be factored any further. I can't divide out a common number. I can't do the AC method. There's no difference of squares or difference of cubes or anything. But what about this 2x minus 8? That one I can actually divide out a 2 from both. So this is going to turn into 2 times x minus 4. So now that we have everything factored, we're going to look and decide, well, what do I have and what do I need? So this first fraction already has the x minus 4 that this one does, but he's missing the 2. So our first fraction, 5x minus 1 over x minus 4, is going to be multiplied by a fancy form of 1, which we're going to use as 2 over 2, to take care of the 2 that it was missing from the other fraction. Now, if we look, our second fraction already has everything we need. It's got the 2 and it has the x minus 4. So in this case, we're actually not even going to change anything about this second fraction. Now when you multiply, so 2 times 5x, 10x, 2 times negative 1 makes negative 2. In this case, we have 2 parentheses x minus 4. Leave the denominators in factored form the entire time. Only multiply in the numerators because the numerators may be able to factor and possibly cancel, but the denominators are already as low as they're going to get, so leave them alone in factored form. So now let's drop down our other one, minus negative 2x over 2 times x minus 4. Now that we have common denominators, 2 times x minus 4 on both of these, we can go ahead and do the operation that it tells us to do in the center, which in this case is subtract. So remember, when you subtract, you have to distribute this negative. So this 10x minus 2 is going to stay, but a negative times a negative is going to be a positive. So this is really plus 2x. All over, the denominators don't get added, they stay the same. 2 over x minus 4. Now we're going to simplify, so I can combine 10x and 2x together to make 12x minus 2 over 2 times x minus 4. So the last step in any of these is make sure you can't factor the top. So the numerator, 12x minus 2, I can see that I can actually divide a 2 from both of those numbers. So the 2 is going to come on the outside, then 12x divided by 2 makes 6x, and then negative 2 divided by 2 makes a negative 1. My denominator is already in factored form, so I don't have to mess with that one anymore. But now you can see that, wait, I have a 2 over a 2. We know that anything over itself simplifies into a 1, so this is just extra information that we don't need. So your final simplified version of this is 6x minus 1 over x minus 4. All right, let's try a couple more examples. So for example 5, we're going to have to factor with the AC method. So again, I need denominators to be the same. When you're adding or subtracting, that's the first thing you have to remember. So factor using the AC method. Luckily, this has an A value of a 1, so we are actually able to use the shortcut here. So your factors are going to look like this. You're going to have an x and another x, and we have to figure out what goes second. So we need two numbers that multiply to a negative 12, but add up to be negative 1. Well, that's going to be a negative 4 and a positive 3. If you need to do it the long way with the table and then splitting apart b, then that's fine. But if a is 1, you can use your shortcut. Now we can look at what we have. So for my first fraction, I have an x minus 4 and an x minus 3. For my second fraction, all I have is x minus 4. So this second fraction is actually missing this x plus 3 part. So we're going to use that to multiply with my fancy form of 1. So we're going to take this guy and multiply it by x plus 3 over x plus 3. So the first fraction isn't going to change. It's going to stay x over x minus 4 times x plus 3. Nothing's changing there. because that has everything we need in its denominator. But this guy is going to change. So we're going to have 5 times x. So we're going to have 5x, and then 5 times 3 makes 15 over, and again, don't actually multiply the bottom out. We don't need to multiply the denominators. We want things in factored form. So the denominators are already ready to go for us. Now, make sure your denominators are the same. So x minus 4 and x plus 3, x minus 4 and x plus 3. Denominators are the same, so we're going to go ahead and add the tops. Add your numerators. So you're going to have x plus. Now when you're doing a plus and you distribute this little plus sign, nothing really happens, which is why we don't really talk about it. So plus 5x plus 15, and again, the denominator is going to stay x minus 4 times x plus 3. Then let's simplify the top. Add your like terms together, x and a 5x to make 6x plus 15 over x minus 4 times x plus 3. Okay, now we have to make sure nothing is going to get simpler. So we're going to take the numerator and we're going to factor that one out too. So 6x plus 15, I can divide as 3 from both of those. So 3 comes on the outside, and you're left with 2x plus 5. And in the denominator, we have x minus 4 times x plus 3. In this case, you can't make anything simplify out, so this is your final answer for example 5. If you have factors that are the same in the numerator and the denominator, then we can simplify those down to a 1 and take out the excess information. Last thing is, well, what happens if I've got all kinds of these complex fractions? So that's these right here. Simplifying the crazy ones. Okay, so x over 3 minus 7 all over 12 plus 3 over x. When you're trying to simplify complex fractions like this, here's what I would suggest. I would suggest looking at the numerator only and the denominator only. So the first thing we're going to do is we're going to look at this and the top only. So for part 1, we're going to look at x minus 3 minus 7, and I'm going to go ahead and make 7 into a fraction because that's the only way that I'm going to add is with common denominators. So let's think about denominators. So I've got a 3 here and a 1 here. So what do I need on this second fraction in order to make them both 3's? Well, I'm going to have to multiply the second guy by 3 over 3. So far we have x over 3 minus 7 times 3 makes 21 over 3. So what your numerator becomes is x minus 21 all over 3. So this is going to be your new numerator here in just a minute. Now that we have the numerator as simple as it's going to get, let's look at the denominator. So that's part 2. 12, and again, I'm going to go ahead and make that a fraction, over 1, plus 3 over x. So just like we got common denominators for the numerator portion, we still need common denominators for the denominator portion. So with this guy, I have a 1 and an x. So I'm going to have to multiply this first fraction by an x over an x in order to make those denominators be the same. So this needs to multiply by x over x. So this becomes 12x over x plus 3 over x. Now my denominators are the same, so I can go ahead and add the numerators. So this becomes 12x plus 3 over an x. So now that I have both denominator and numerator simplified as far as they're going to go individually, let's go ahead and put everything back together. So the blue one is my numerator. Oops, I need blue, not purple. Or pink, whatever that is. So x minus 21 over 3 is my new numerator, all over 12x plus 3 over x. So this is step 3, putting it all back together. Now this looks like something that we did when we were doing multiply and divide. Remember when you have fractions, fractions just mean division. So think way back, how are we going to divide fractions? Well, that means we are going to flip the denominator, keep, change, flip. So keep the numerator. So x minus 21 over 3, keep the numerator, change division to multiplication, and then we're going to flip the denominator. And now we have a multiplication problem. Well, multiplying fractions is easier than adding. I don't need common denominators anymore. we're just going to multiply this stuff straight across. So what this turns into then is we're going to leave everything in factored form as best we can. I'm going to put the single x in the front, x minus 21, over 3 times 12x plus 3. Now let's see. 12x plus 3, I can actually simplify that. I can factor out a 3 from this stuff. So when you factor out a 3, numerator stays the same. You still have the original 3, but then I'm going to factor out another 3, and you're left with 4x plus 1. So now we have x times x minus 21 all over. 3 times 3 makes 9. 4x plus 1. Make sure nothing can simplify down to a 1 and be deleted. In this case, we do not have anything to simplify down to a 1. So this is our final answer for this complex fraction. Just because they look scary doesn't mean they actually are. Okay, got one last one. This guy. So for one like this, you really only have to simplify the bottom. The top is already as simplified as it's going to get. So I can't make 6 divided by x minus 2 any simpler than it already is. So we're going to focus on this guy down here. So we've got 1 over x minus 2 plus 3 over x. So we need common denominators. So ask yourself, one of them has an x minus 2, one of them has an x. So this first fraction is missing the x that the second one has. So we're going to multiply the first fraction by x over x. Then my second fraction is actually missing the x minus 2. So we're going to multiply by x minus 2 over x minus 2. This will make sure we have common denominators. So 1 times x makes an x. Then leave your denominator in factored form. We don't really need to worry about multiplying the denominator back together. Multiply your numerators. It's usually simpler anyway. 3x minus 6. Let me fix my 3 and make it look more like a 3. 3x. There we are. And then leave your denominator in factored form. These are, in fact, the same. So we're going to go ahead and add the numerators together. So you have x plus 3x minus 6 all over x times x minus 2. Okay, combine your like terms, x plus 3x, 4x minus 6 over x times x minus 2. So this right here is your new denominator. That's your new denominator. We haven't done anything to the top yet. We only worked with the bottom. So what we need to do is we need to put everything back together. So in our original, we had 6 over x minus 2 all over. Now this is the new denominator with all your denominators simplified as far as it's going to go. So simplify your denominator first, then put it all back together. Now we have the same kind of situation we had a minute ago. I've got one fraction divided by another fraction. So how do we divide two fractions? That's your keep, change, flip. Keep, change, flip. So we're going to keep the first one, 6 over x minus 2, change the division to multiplication, and then we're going to flip this guy, 4x minus 6. Okay, so with multiplication, you don't need common denominators, you're just going to multiply straight across. So what happens is this guy becomes 6x times x minus 2 all over x minus 2 times 4x minus 6. Now if you notice, we have x minus 2 and x minus 2. Well, anything over itself is a 1, so that's extra information. So now we have 6x over 4x minus 6. But remember, before you say I'm finished, make sure you can't factor out anything else. This denominator down here is a 4x and a negative 6. Well, I can divide a 2 from both of those. So I've got 2 and then 2x minus 3. And the reason we needed to do this is because now I can simplify 6 over 2. 6 over 2 simplifies into, that would make a 3 over 1. So it's going to be 3x over 2x minus 3. That is as simple as it's going to be. So this is your answer to that simplified complex fraction up top.